Hello. So I posted a short video the other day about how to make a wall family in Revit or any system family in Revit using a in-place model group hack thing. And I got some questions about how to work with different um, things that you would connect to a system family, like um, hosting windows and openings and um, fills along those, both in the ends and inserts and so on. And I thought I'd show you an example of how I use this method. This here is a facade element in Revit that I would model this way. It has an insulation layer that is a wall, but as a point-based family that I can use for modular construction and fabrication and design, basically. So this is a wall, and this is a wall, and this is interior cladding, covering the inside of protecting the insulation from the inside of the building. This is a window, point-based window as well, just a frame and a glass. And then there's some covering element on the outside of the facade that's also built up as a point-based concrete and stone facade element as a wall, basically using the same procedure for all of these different families. So all of them are nested shared families that I put together in a MT family, basically. That's in this case called the facade module, where I basically constrain or change the dimensions of all of these different things using basic parameters. So what I do is I set up width and height and thickness and placement parameters for all of these different components, and then I change them, and then the different slave components, if you want to call them, follow these parameters through either dimension constraints or associating parameters between the master family and the component families. This works really well for me. I would say like so as long as you don't use like wall-based families to cut the openings. In this case, I've just added a void inside that we can have a look at it. So this insulation family, if I open this family, it looks like this, and I've added a void, a couple of voids actually, for both hosting the frame of the window, but also the opening itself, and a void for the slab edge to go a little bit into the facade element. And then I place the window in the same place and make sure that the parameters controlling the width and the height and the placement of the opening dictates the placement of both the openings in both the insulation component and the covering component, but also the size and the dimensions of the window and the facade cladding element. And it's not so complicated to do, and the end result can be pretty sweet. Actually, you get like complete control of a modular facade system, and if you have like hundreds and hundreds and hundreds of like big building, lots of facade elements, I normally use DynamoScript to just place them out, rotate them, put them on different levels, control the height, perhaps, and the width, and the corners are all, depending on the design of the building, of course, but corners can be a little bit of a tricky one. Corners are great with like normal walls and requires more math normally, especially if you don't have a completely rectangular building. So pros and cons with every approach, like everything in life. I put them together in a small sample model. So there's like, when you work with families, there's no limit to the amount of intelligence and complexity that you can build it, and complexity in a positive way, not in a negative way. So these models here, because I'm using nested shared families, this is a component, this is a component, the window is a component, the covering is a component. In this case, actually, even I've made a sill component here because the contractor wanted to order the sills, prefabricate the sill elements, and then put them in the master component, and then ship them onto the site, and get complete control of the size and dimensions and materials and so on. So this is a really nice way for me to work, and I really like that hack that I showed the other day, because these are still, it's a wall. This component here is a wall, this component here is a wall, even the covering is a wall, although probably you can say that it shouldn't be. But that means that if I go to visibility graphic overrides in terms of walls, what you would expect to get turned off gets turned off, as opposed to, for instance, if you were using generic model families and then hacking around with IFC classes to make it an IFC wall. You don't have to do that in this case. And even as a bonus in the end, guess what? It's room bounding. 3 room separation lines, but the facade is naked, so this is still a room bounding element, although it's a point-based generic model wall hack thing. Knock yourselves out, guys. I'm going to try to find a way to upload this file somewhere so that you can look into how I build these families. Ciao!